You may have heard it said that you can only take square roots of positive numbers. And the reason is any number squared is always positive. You'll never get a negative number unless we define this variable I squared to be equal to -1. If I squared equals -1, then taking the square root of both sides gives us I equals the square root of -1. This is called an imaginary number. I, the square root of -1, is an imaginary number. Now, I want to be careful with that name. A mathematician many years ago did not like imaginary numbers, and he thought they were ridiculous. And so he gave them the name imaginary numbers to imply they were not actually existing numbers. These numbers do actually exist. They have many applications in engineering, especially electrical engineering. The name makes it feel like they're not existing numbers, but they do actually exist. And they allow us to simplify many expressions. As we simplify expressions, we're going to simplify the square root of -1 part before we simplify the rest. Let's take a look at how this plays out in actual practice. Let's say I want to take the square root of -45. The first thing I'm going to do is take care of that negative. The square root of a negative number is the imaginary number I. And then we'll look at the 45 to see how it can simplify. 45 is 3 times 15. And 15 is 3 times 5, which means we've got 3 squared times 5. Well, we already know that 3 squared under the square root can come out, so we end up with 3i square root of 5 for our simplified expression. Let's try another example. Let's try to take the square root of -6 times the square root of -10. Again, we're going to simplify those negatives by pulling out an I. Let's also factor the 6 while we're at it, 2 times 3. Take care of that negative by pulling out an I. The square root of -1 is I. Leaves behind a 2 times 5. And this is where it gets interesting, because now I see I times I. I times I is I squared. But remember, I squared equals -1. So we have a negative. Also, under the radical, we see 2 appears twice. That means we can pull a 2 out, leaving behind 3 times 5, which is 15. So the square root of -6 times the square root of -10 is -2 square roots of 15. Let's try one more example. Let's try 20 plus the square root of -80 all over 8. Well, let's factor that 80. I'll go off to the side here, which is 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. So what we really have is 20 plus, take care of that negative, it's an I, square root of 2 to the 4th times 5, all over 8. Well, that 2 to the 4th can simplify. Dividing 4 by 2 gives us 20 plus 2 squared I root 5 all over 8. Well, 2 squared is just 4. I'm going to go ahead and put that in there. So now we have 20 plus 4i square root of 5 over 8. If I want to simplify this, we have to divide all 3 terms by the same thing. So maybe a better way to handle it would be to factor out a 4 out of both the 20 and the 4. Leaves behind 5 plus I root 5 all over 8. And now that that's factored, I'm allowed to reduce, because we can only reduce factors. Factors are multiplied. We cannot reduce if there's any adding or subtracting. Those are terms. Terms cannot be reduced. Only factors that are multiplied. But the 4 over 8 can reduce to 2. And when I do that, we get 5 plus I root 5 all over 2. So by creating this imaginary number where I squared is -1 and I is the square root of -1, we can do operations with negative radicals by simplifying the I first and then simplifying what's left.